So we're going to be setting up our first experiments today, and before you begin, it's already written, but I need to make sure you remember this. You have to have tested that your car can successfully travel down the ramp with the three calculators in place. Today's test, you're not going to be using the calculators, but we can't modify our car in any way from this point forward. So make sure it's ready, because once you start these tests now, the modifications can't happen. We need to keep the car exactly consistent for all of our future tests.
We are going to review how we are setting up our coordinate grids to be an accurate measurement tool for the path that our car is traveling. And just a reminder, we're doing this because our car is traveling more than just a vertical path. It is also traveling horizontal. So we are going to set up our coordinate grid. You should be using a ruler to draw on your graph paper, but for these purposes I am not. So our x-axis is going to be the lateral or horizontal distance, and the y-axis is going to be our vertical distance. So you need to be aware of approximately how far your car is traveling before you can really set up your range. So the first thing we need to place into our x-axis is we need to have the ramp location. Thinking about the way your car travels, if the ramp were located here on our graph and your car was going to travel, and if it left the ramp and traveled to the left, we would run out of space. And if it traveled to the right, we would have plenty of space. So we want our ramp location to be in the center of our graph, so that if the car veers left or veers right, we still have space for it. So as I'm setting up my graph, I'm going to use my measuring tool and say that obviously this is 0, and we're working in inches. And then each marking, I'm going to go by a half of an inch, because that gives me plenty of accurate measuring space. Now again, you should be able to write a little bit neater. It's a little bit more challenging to do so in this application. So as I am going across, I'm going to start to number every other, because I know my halves are in between. Now I've measured my ramp, and I know that the width is 9 inches. So using my highlighter, I'm going to highlight 9 inches in the middle of my graph. So to do some math off to the side, I have a total of 14 inches minus 9. That gives me 5. So that means divided by 2 is 2.5. I should start at the 2.5 mark and end with 2.5 inches on the other side. So I need to backtrack a hair at 11.5. That highlighted distance is the width of my ramp. So as I'm looking at my graph, I'm realizing that I don't have a whole lot of space to veer off to the left and off to the right. My car is going to need to stay relatively in the width of my ramp. If your car tends to turn a lot, this graph needs to be wider. My car travels relatively straight, and so I'm confident in the fact that I can use this graph. So, for my vertical distance, you need to run a few tests on your car and try to get an average range of the distance it's traveling. I know that mine travels usually in the range of 30 to 40 inches from the ramp. So, I know how to set up my scale. I want to use something as accurate as possible. If I were to count by fives, it's not going to be accurate enough. Counting by ones, my graph is going to be way too big. And counting by twos, it's still slightly too big. So I'm actually going to count by threes. Now that may seem like a slightly odd amount, but the bottom line is counting by threes is relatively simple. And when you think about the distance between each block from 0 to 3, that means I just have to account for 1 and 2 in the middle. So it's easy to graph in the middle of my blocks. So I'm going to continue to count by threes. And again, you should be writing as neat as possible. It's a little bit more difficult for me on the iPad. I want to make sure that I'm accurately counting by threes and I have no fact mistakes. That's a 45 and 48, 51, 54, 57, and 60. And I'm confident that my car will consistently fall short of the 60 inches. If your car is traveling farther, perhaps you'll be using a longer graph, or perhaps your scale will be slightly bigger. I encourage you to use the smallest scale possible to make your graphing as accurate and exact as possible, but you also need to be reasonable with the space you're using. I'm confident that your paper will have slightly more space as well for you to go a little bit farther and use a very accurate scale. So I have my graph set up for my car runs. So now we're going to review what the car run looks like and how we are measuring and plotting.
So we're going to be looking at how to set up our data experiments today. So it's very important that we are setting it up in the most accurate way possible. And it's not going to be perfect, but consistency is key when we're performing our data experiments to learn about our laws of motion in our physics principles. So, as you can see, I have my 6 books set up. Now, we're going to be measuring lateral and vertical distances. So it's important that your books are right in line with this tile line on the side. Okay? Because when I set up my ramp, I'm going to have the ramp at the back edge of the books. Okay, so my ramp is at the back edge of the books. And now, as you can see, and if I move back a bit, that my ramp continues in line with this tile. And as you continue to see the ramp, it's coming out straight in line with this tile. So now I know that this tile line is exactly in line with the left side of my ramp. And I can use this for measuring purposes. So if we're thinking about our graphs, this point on my graph, near the y-axis, is this point on my ramp. And this here is on my x-axis, going to the left and to the right. So now we are going to be releasing our cars, and it's important that you've already tested that it can successfully travel with the calculators. So now we're not going to do it with the calculators, we're actually going to use our empty cars. And when I'm setting up my car, I always want to be consistent. So I'm going to line the wheels up just at the back. I'm going to try to line it up straight and I have it in the center of my ramp. So I can release my car and watch it travel. So now we need to worry about the measuring. Measuring is going to be very tricky in the beginning, but once you get used to it, it's just going to be important that you're thinking about what you're doing, you're taking your time, and you're measuring very accurately. We're going to be measuring the location of all four wheels on our coordinate grid that we created. So the measuring needs to be precise, and you're going to have to work together to do it successfully. So the first one I'm going to measure is my front left wheel. So I'm going to use this tile line as my guide. I know that if I place my 0-inch mark at the front of the ramp and I follow this line, make sure I'm using inches. Okay, I'm using inches. If I place this here and stretch it out along the line, I know that this tape measure is following a straight path, the exact location of this front corner. Okay, and so one person should be holding this, but I'm going to get it very still since I'm by myself. Now, I need to measure the location of this wheel. We're always just going to use the bottom part that's touching the ground, the center of the wheel. So, I can see that the center of the wheel is coming in at 28 and a half, and it is 1 inch from the tile line. Now we don't need to measure perfectly exact, but we should be measuring to the nearest half of an inch. So what I want you to realize when I'm measuring over here is I am starting my measurement from this side of the tape measure because that's following the tile line, not the opposite side. It's things like that that you need to pay attention to and think about as you're measuring.
So I'm ready to place my front left tire, and it came in at 28 and a half, which is approximately right here, and 1 inch. Now here's the tricky part. I'm not graphing it at 1 inch here. It was 1 inch in from the left side of the ramp. Let's visualize what we did. I measured the tile line following the outer edge of my ramp. So it's actually at the 3.5 because that's 1 inch in from the ramp. So I'm going to follow the 3.5 inch mark and mark it as best as I can. Remember, yours should be much more accurate because I'm using an iPad at the 28.5 inch mark. There's my front left tire.
Okay, so now I'm ready to measure my back left tire, and I can see that it is actually right on the tile line, and right at the 22-inch mark is the center of the tile. So that was an easier one to measure.
Now I'm ready to graph my back left tire. It was on the tile line, so remember that is not the y-axis. It is on the ramp line, and it was 22 inches out. So following my ramp line, and I can graph at the 22-inch mark, doing my best to be accurate, and there's my back left tire. So you can see that it's out of line and it looks dramatic, but it's only a difference of an inch. And my car has a tapered shape because the back left tire is out from the front left tire.
So for my back right and my front right, to measure across, I'm not going to be able to do it accurately because I have to travel through the car. So I need to measure from this side of the ramp. The problem is that I could be angling towards the center or away from the center and not really ensuring that my tape measure is straight. And it looks straight, but the problem is that it might not be perfectly straight. And we want to make it as accurate as possible. So I know by measuring that my ramp is 9 inches wide. So if I set my ruler to the tile line, I know this tile line is in line with my ramp, and I can pull my tape measure so that it is on the 9-inch line. And then I can slide my ruler farther down, and again, straighten my tape measure so that it is on the 9-inch line. Now notice I'm struggling a bit because I'm doing it myself. You should be working as a team to hold these tape measures accurately. And now I'm going to take my tape measure straight past the car, and again, I'm going to line up my 9-inch line. So it's 9 inches there. I'm going to go back and check. 9 inches here, and 9 inches here. So now I know this tape measure is traveling straight with this side of the ramp, so my measurements can be accurate again. So my front right tire, I'm going to fold my tape measure over at the 0-inch mark to get rid of the end. Place it in the center of the tire. It's coming at 28.5 from the ramp and 4 inches in towards the center.
So for my front right tire, it came in at 28.5, which is actually exactly in line with my other tire, and 4.5 inches in from the right side of the ramp. So it's 4.5 over from there. So if I go a half, I'm at 11, and 4 more inches would be at the 7-inch mark. So 7 inches and 28.5 is going to be my mark. Okay?
Now to measure my back right tire, again, I'm just going to double check that I'm still at 9 inches. Okay. Okay, still at 9 inches. And I can see that. I'm going to fold my 0 over again, place it in the center of the tire, and it's coming at 22.5 away from the ramp and 2.5 towards the center.
My back right tire came in at 22.5, which is slightly above my other tire, and it came in 2.5 from the edge of my ramp, so 2.5 in this direction. So I'm going to be following the 9 line up to the 22.5. So once we have our 4 tires, using a ruler, I can connect my dots and see my first car. That is where my first car ended after my run on the ramp. When you graph your next car, you need to use a different color. Okay, we need to graph with different colors to see each of the different data points. Now, as you can see, the back of my car is very close to being in line with the ramp, and it's also finishing very close inside the ramp. Now, perfectly straight would be more in the center of the ramp, but I can see the kind of the direction that my car is traveling plus the overall vertical distance. And both of those features are going to be important because you're going to need to be able to have your car travel in a straight direction, but we're also going to look at factors that allow our car to move farther and move less, because you're going to have to figure out a way to manipulate the distance that your car is traveling.